In this video, we'll be covering the joints of the body. We have three general types of joints: fibrous, cartilaginous joints, and synovial joints. The reason we have fibrous joints is to allow for minimal to no movement between two bones. So we have three types of these fibrous joints. We have sutures, Syndesmosis joints, and Gomphosis joints. The Gomphosis joint refers to the joint between the teeth and the gums, which is nice because it kind of sounds like it. So we have the Gomphosis joint again would be here, Gomphosis joint. The sutures, as you learned previously, are the tight connection points between the bones of the skull. So we have the sagittal suture and the lambdoid suture, just to name a few. Lastly, the Syndesmosis joints is between the radius and the ulna and the tibia and the fibula. And it's these joints that is in between the two bones that prevent them from pulling apart. We then have two examples of cartilaginous joints: the Symphysis and Synchondrosis joints. An example of the Symphysis joint is the vertebral discs in between the vertebrae. Symphysis joints are united by a fibrous cartilage and are mostly stationary but do allow for some movement. For the Synchondrosis joint, the primary example is the cartilage that connects the ribs to the sternum together. These joints are made of hyaline cartilage and have very little movement as well. The synovial joints allow for the really large movements of the body. One way to make them stick is to do the movements and learn the movements that are performed with that joint. So there are 6 types of synovial joints, and they are the ball and socket, the ellipsoid, that can also be called condylar joints, the planar, which can also be called gliding joints, and then the saddle, hinge, and pivot joints. The primary ball and socket joint can be found in our hip, where the head of the humerus articulates with the acetabulum of the pelvic bone. So you can see here how it's literally a ball in the socket to allow for a lot of movement. Another example of this is the head of the humerus that articulates with the glenoid fossa in our shoulder. You can see how these ball and socket joints allow for a large range of movement. The primary ellipsoid and condylar joints are in the wrist and ankle. They resemble a ball and socket that allow for lots of movement, but they're a little bit more oval in shape. So you can see this here in our wrist, how it allows for lots of movement. The primary planar or gliding joints we will be discussing are the ones between each of the carpal and tarsal bones. As you move your wrist around, you can imagine these bones sliding over each other, which allows for some movement. So you can see how they just slide over each other. Another example of these is between the vertebrae. So we can see here how we have the inferior articular facet of one vertebrae articulating with the superior articular facet of the one below it. And you can see here that as you would bend over, these joints would slide over each other for the movement of the back. For the saddle joint, the thumb is the primary one we'll be going over. And it is called the saddle joint because the end of each bone resembles a saddle. You can kind of see it on this model, but since it's connective, it's not super good. But it'll be this joint here. And the best way that I like to remember this is because you can feel it on yourself when you rotate your thumb around. There's that little bump that you have to get over. And so that's you getting over that saddle portion of the thumb. Another saddle joint is the sternal end of the clavicle and the clavicular notch of the sternum. In the body, those are the only 2 saddle joints. Examples of the hinge joint are the ulna and the humerus, and the femur and the tibia. So we can see here with our humerus and our ulna how they just hinge back and forth like this. So this would be our hinge joint. Lastly, we have an example of a pivot joint, which is between the radius and the ulna, and this allows for the crossing over of the radius and the ulna. So you can see right up here, how this would be described as a pivot joint. And then our last pivot joint is going to be between the atlas and the axis. You can see here, and this is what allows our head to turn side to side. That will be it for our joints.